All right, so we're here to take a quick look at Lab 7.6, which is essentially I call Ohm's Law Lab. It's confirming our relationship between voltage and current. So we're going to be doing that. The purpose is to verify Ohm's Law experimentally. So in class, we do this by using some resistors and setting up a circuit with four batteries, some wires, a battery pack, and a resistor between 20 and 60 ohms, and then we use a multimeter. Since we're doing this digitally, we are going to have to go ahead and use our simulation again, and I have one quick thing that I'm going to talk about for that. So we're still just gonna let's go to the lab real quick, and let's go ahead and go to the lab. It's not done correctly. Awesome. It's not set up as a title. So there we go. Lab 7.6. Yep, it's set up as a title instead of heading one. Perfect. There we go. Now it's fixed. Now it should pop up in your table of contents. But we're going to be using instead, again, we're going to be using our simulation. So let's go ahead and open this simulation. And now let's refresh this, and there's lab 7.6. Awesome. So we're verifying Ohm's law. So normally we would set up a couple of batteries. We can use the regular DC construction kit. You can also use the lab. It doesn't really matter. That's just adding a couple facets that we don't need to worry about right now. But we're using essentially just different amounts of batteries, what their voltage is, and then um, the current that's going through the circuit. So I'm going to set up one battery, start with that, and a resistor. Now for this lab, go ahead and click on your resistance. And what I want you to do to make it unique for you is I want you to take your last two digits of your student ID number and make that your resistance. So my student ID number was 11077. So I'm going to go down to 77, and I have 77 ohms of resistance. Now you can see that the colors change with that, and that is a lab that we do called the Color Code Lab. We're not going to be doing it this year due to coronation, but the bands mean specific things. So make your resistance the last two digits of your student ID number. Now, if you have like an something less than 10, like you have oh 06, make it 66 or 50. If you have oh 05, make it 55. So make your resistance two digits. If you're less than 10, just double it, or double the number so that you have a nice resistor set up. So then all I got to do is connect the battery across the resistor using these couple of um, wires, and you can see right away that we have a flow of current. Now my voltage is only 9 volts, so if I were to take a look at that, I can verify that here. That says 9 volts. And since we're assuming that these wires are ideal wires, as we talked about in Ohm's law in the Ohm's law section, um, we can see that the voltage drop across the resistor is also 9 volts. So it should equal the voltage drop across the battery. Then I'm going to take my ammeter here, which measures current, and I'm going to put that in line. Now, with an actual real life situation, obviously we can't just stab the wire. Instead, we place the leads of the ammeter, like just like how we have the voltmeter, we place the leads of an ammeter that breaks the circuit, because the ammeter needs to be in line to see what the current is. So if you ever deal with a multimeter, get a little help with that and the difference of how you set up a voltmeter versus how you set up an ammeter. So here I have 9 volts and my current is 12 amps. Or I'm sorry, 0.12 amps. So your current might be in amps, it might be in milliamps. Because our voltages are so high, we should have current in amps. But then in the table, that's all you're going to fill out. So for one battery, it's 9 volts, and my current is 0.12 amps. And I'm going to get rid of the milliamps because I don't need it with this simulation. And then all you're going to do is you're going to do that for one battery, two batteries, three batteries, and four batteries. So let's go ahead and cut that. And now we'll go ahead and do a second battery. And I know with the second battery, Oh, let me just get that attached. My current is now 0.23. If I go and check my voltage, it's 18. So now I have 18 volts and 0.23 amps. Now, again, you're going to have different numbers than I will because your resistor is going to be different. But you're going to do that for 1, 2, 3, and 4 batteries. Then you're going to create a graph with that. You can use any graphing software you want. I'll go ahead and pop in Excel. So here's Microsoft Excel. Let me go ahead and just make that smaller for right now. But on the x-axis, we want to do there's different ways you can do it. I'm going to do voltage on the x-axis, and here's why. Measured in volts, and current on the y-axis measured in amps. Here's why. The reason is what we're manipulating is technically the voltage. So I'm going to do 9, 18, then it would be 27 and 36. And I'm going to make up some numbers, 0.12, 0.23, 0.36, and 0.48. So it should be something like that. We go ahead and we'll make our graph. If we go ahead and insert our scatter plot, and boom, I get a nice, what makes sense, a linear fit. So you're going to add the linear fit. So if you add the trend line, and we will do linear fit, display equation, display r squared. Intercept should be 0, 0, because if I had 0 batteries, I would have 0 current. And I get a slope of 0.0133. That's my value right here, the slope. Well, if I think about this graph is technically, I have current on the y-axis and voltage on the x-axis. So I have I over V right here. So if I were to take the inverse of that, it would be V over I, and that would equal my resistance. So if I go ahead and grab my calculator, and I have 0.0133 was my slope. Well, if I go ahead and instead of that, I'm going to do 1 over that. So 1 divided by 0.0133, I get 75.18 ohms. So that's my current. And so that was my resistance. What was my resistor? Well, I set it up to 77. So there's a little bit. I didn't actually gather the rest of my data. Hopefully that would clear it up. But that is how I can finish off the magnitude of the slope. And the slope represents the inverse of my resistance. So the actual resistance would be 1 over that. I did say here, though, you could change and put current on your x-axis and voltage on the y-axis, and that will give you a slope of the resistor instead of the inverse of the resistor. So whatever you do is totally fine, just so you know how you're setting up that graph. Slope represent sources of error. In this case, there really shouldn't be much except the fact of how is this guy kind of working. And that's pretty much it for this lab. So that's lab 7.6, the determination or the relationship between voltage and current, otherwise known as Ohm's Law lab. Good luck. Let me know if you have any questions.